This might seem a bit weird, but listen to this fictitious one-sided phone conversation for a moment. Hey Dad, what's up? Oh, your computer isn't working? All right, I can help you try and figure out what's going on. So, what specifically isn't working? Okay, when you say Excel isn't working, what exactly do you mean? So it's not even opening up? Hmm. When was the last time you used Excel? Last night? Okay. When you used it, did you notice anything weird or did you see any error messages? No errors? Hmm. Has anything changed on your computer since last night? Nothing at all changed? You didn't install or uninstall anything by chance? No? Okay. Has anybody else used your computer since last night? Oh, the grandkids were on the computer all morning? All right. Well, have you tried restarting it? No? Okay. Let's go ahead and restart your computer and try opening Excel up again. It worked? Cool. Okay, I'm pretty sure most of you who are watching this video have had phone calls very similar to this one. Asking my dad to just restart his computer kind of feels like a cop-out, but it's extremely effective in these types of situations. I mean, I could try and really dig into the problem with his computer, but there's a pretty good chance I'll fail because I really have no idea what things led up to the problem, and I'm probably not going to be able to figure out what happened from my dad because he's just not paying attention to details like you or I might be. Okay, so what does this have to do with Elixir? Well, I'll explain in a moment here, but first, I've got a semi-hypothetical question for you related to the exit polling web application we're going to start building in a bit here. Do you think you can tell me every possible way the application could have errors? Now, to be clear, I don't mean right now. I mean, by the time we're done writing the app, do you think you'll be able to tell me every possible way the application could have problems? There is only one correct answer to this question, which is no. Regardless of how good a programmer you are, you can't do it. There's just no way you can account for every possible error in the programs you write. Let's consider for a moment a fundamental difference between Elixir and pretty much every other popular language. In most languages, resources are shared. For example, consider a web server written in Java. In a Java server, memory can be shared across all threads that are servicing independent requests. And the thread that the Java server uses to service one request is often the same thread that's used to service subsequent requests by other users. In Node.js, even more things are shared. Here's what I mean. Every request to a Node.js server is serviced by a single shared thread, and similar to Java, memory can be shared across all requests as well. Now, in Elixir, things are quite different. In an Elixir web server, processes are created to service each request, which is somewhat similar to having multiple threads in Java, but the big difference with Elixir is that nothing is shared between Elixir processes. For example, each process gets its own private memory, among other things, and each individual process is dedicated to servicing a single request. In other words, each process in Elixir is completely isolated from other processes. If we model these three languages visually, it might look like this. In Java, we've got one big circle that represents shared memory, and every thread operates in that circle. In Node.js, we've got one big circle that represents both shared memory and the shared thread, and every request is serviced within this circle. In Elixir, there isn't one big circle. There are many small, isolated, independent circles, or processes. Okay, so what's the takeaway from this visual? Well, let's consider error handling with respect to these three models. In Elixir, if you encounter an error while servicing a request, the worst thing that can happen is that a single one of these circles or processes dies, but overall the effect is pretty minimal because each process is isolated from the other processes. In Java, if you encounter an error while servicing a request, the worst thing that can happen is, well, not good. You could corrupt the shared memory, which can affect other unrelated requests, and potentially the entire server could crash. If you encounter an error in Node.js, the worst thing that can happen is the shared execution thread could die and kill the entire server. Now, because most popular programming languages have models similar to Java or Node.js, you, the programmer, have to program in a very defensive way because the consequences of errors can be huge. In other words, a small error in one request could lead to system-wide problems and outages. Let's dive a bit deeper and take a closer look at server-side programming with Node.js. Now, as I said a moment ago, when you're writing a server in JavaScript, your server is going to be running a single thread to service potentially hundreds of concurrent requests. Think about the consequences of an unexpected error on your Node.js server. In other words, imagine what would happen if you were servicing 100 concurrent web requests and just one of those requests encountered an unexpected error. That single error might kill the Node.js server, which would interrupt the other 99 requests, and your server would be down for a short period of time until it was restarted. Not good, right? Another possibility is that the error might not kill the Node.js server, but it might put it in a bad state where every subsequent request has issues, at least until the server gets restarted. Now, again, because of these risks, the JavaScript programmer has to program very defensively. So what do I mean by defensive programming? Well, it means you've got try-catch blocks all over the place. And it means you might be reluctant to use recursive solutions because of the risk of creating Stack Overflows. And it means you don't trust other programmers, so you do everything you can to protect your code from other people's code. And it means you're scared of the unknown unknowns, and sometimes you don't sleep well because of this. In summary, you've got to code in a way that minimizes the risk of one error having mass consequences on your server. But in truth, you'll never be able to anticipate and handle every possible problem, and periodically, these errors will kill your server, cause outages, and lead to debugging sessions that can last for days or even weeks. And worst of all, these problems result in frustrated users. Error handling in Elixir is quite different than what you'd do with pretty much every other popular programming language. So what's different about Elixir? Well, let's contrast web requests in Elixir with web requests in Node.js. So imagine an Elixir server is servicing 100 concurrent requests. In Elixir, a process is created for each of the 100 requests, and if you encounter an unexpected error in one of the processes, the error might kill the process and fail to service that one request, but it won't affect the other 99 requests because each of the 100 running processes are completely isolated, and that one error definitely won't bring down your server. It's isolated, so it literally can't bring your server down. So considering the fact that there is no possible way for you to anticipate, catch, and handle every possible error, and considering the fact that errors in Elixir don't have the severe adverse consequences experienced in other languages, it's worth asking the question, should I think differently about errors in Elixir? Well, you should, and Elixir programmers do think differently about errors and how to deal with them. In Elixir, we accept the fact that unexpected errors are going to occur, and there's no possible way to anticipate every possible error, so we say if there's an unexpected error, we'll just let the isolated process crash. Now, this different paradigm for dealing with errors, let it crash, doesn't really tell the full story. You might hear the phrase, let it crash, and think that Elixir programmers don't care about errors and bugs, but that's not the case. When a process crashes, we care. We want to know what happened, so ideally there should be some reporting mechanism, such as logging, so we can dig into the underlying issue and fix it. Because we do care about errors, we're just dealing with them in a different way. Now, let's think about let it crash in terms of short-lived and long-lived processes. First, let's consider a simple mental model of the processes we'd want to use in an Elixir web server. First of all, we'll probably need some sort of long-lived process that's running on the server, just waiting and listening for new requests. Now, when a request comes into the server, the long-lived process will see the request, then it will create a new short-lived process to actually service the request. If one of the short-lived processes runs into an error, it'll just crash, and unfortunately, it won't be able to service the request. So should anything else happen in this scenario? No, not in that moment. The request came, the process failed, Hopefully something useful was logged, but there's nothing else to do right at that moment in time. I mean, what would you even try to do? Okay, so that's a simple error scenario for short-lived processes. But now let's think about errors for long-lived processes. So for example, what if this long-lived process here crashes? Are we okay with this process just dying and going away? No, not really. If this process isn't up and running, our server can't respond to requests. Basically, our server would be dead. So what do we do if this process dies? Well, we could try and be defensive and catch errors to keep the process from dying, but again, this is a losing proposition. At some point, an error will occur in this process that puts the process in a weird state where the process appears to be up and running, but it's not actually working like it should be because it's in a weird state. This is kind of like my dad's computer problem from my phone call. His computer appears to be up and running, but it isn't really working properly because it's in a weird state. What if we treated errors with long-lived processes kind of like I did with my dad's computer? In other words, what if we just let the process die, and then we had something automatically restart the process to put it back into a known, good working state? Well, that's exactly how we deal with long-lived processes that crash for whatever reason. So how do we restart a long-lived process that crashes? That's what we'll start to look at in the next video.